Have you ever given a thought on how internet reaches your home so fast? Or how data is transferred from one place to another within a very short span of time, also without being distorted at all? Well, thanks to optical fiber cables. Welcome to the third episode of Mesmerized by Light, presented by Optical Bangladesh Student Chapter, University of Dhaka. In this video, we will be talking about how light can easily analyze the properties of a material by using optical spectroscopy. Let's now see what optical spectroscopy is. Optical spectroscopy is a technique that uses light, or to be exact photons, to analyze and measure the properties of a sample. It is widely used to study the properties of material, identify known substances, and also for diagnose diseases. To perform optical spectroscopy method, we need a light source, a sample to analyze, and a detector to measure the resulting signals. In a very traditional spectroscopy method, these components are connected using lenses and mirrors, which we can see in the picture. But this arrangement gets quite bulky and requires precise alignment. But our optical fiber is the one that solves all the problems we face in a traditional spectroscopy method within a snap. Not only that, optical fiber offers several efficient and flexible alternatives as well. First of all, this optical fiber is a thin, flexible and transparent cable made of glass or plastic which can transmit light over long distances with minimal loss or distortion. And the low attenuation and dispersion properties of optical fiber allow for the efficient delivery of light to a sample and the detection of the resulting signals. By using optical fiber, we can connect the light source, the sample, and the detector using a single cable, which eliminates the need for bulky optics and precise alignment. Also, these optical fibers are less likely to get damaged by the environmental factors such as moisture, temperature changes, or vibration. They are also not likely to break due to physical stress, making them more reliable. Most importantly, this optical fiber offers a high degree of precision and accuracy in spectroscopy measurements. The use of optical fiber can significantly reduce the potential for errors associated with the traditional measurement techniques. If we give a closer look at optical fibers, we can see they are thin strands of glass or plastic that are used to transmit light signals over long distances. As we can see in the picture, the basic structure of an optical fiber consists of three layers. The core is the central part of the fiber where the light signal travels. It is made of high purity glass or plastic and its diameter is typically between 5 and 10 microns. The core is surrounded by a layer of lower refractive index material called cladding. The cladding serves to confine the light within the core and prevent it from leaking out. The outermost layer of the fiber is a protective coating that is used to protect the fiber from damage and environmental factors. It is typically made of plastic or a similar material. Also, there are some other coatings such as plastic fiber covers and cable jackets which are used for strengthening the fiber cables and to minimize the effects of environmental factors. The light signal is transmitted through the core of the fiber using the principle of total internal reflection. When light travels through the core of the fiber, it bounces back and forth off the walls of the core due to the difference in refractive index between the core and the cladding. This causes the light to travel down the length of the fiber without significant loss of intensity. Here we can see another optical spectroscopy method using optical fibers known as optical emission spectroscopy or OES. OES is a technique used to analyze the elemental composition of materials by measuring the intensity of light emitted by excited atoms. OES works by exciting the atoms in a sample using a high energy source such as a plasma or an electric spark. This excitation causes the atoms to emit light at specific wavelengths, which can be measured and analyzed to determine the identity and concentration of the elements present in the sample. OES is commonly used in material science and the analysis of trace elements in various materials. It is often used to analyze the elemental composition of metals, alloys, and other solid materials, as well as to monitor chemical processes and industrial production processes.
One of the major advantages of OES is that it is a non-destructive technique, meaning that the sample being analyzed is not damaged during the analysis. OES is also a very sensitive technique capable of detecting trace amounts of elements in a sample. Additionally, OES can provide quantitative information about the elemental composition of a sample, allowing precise measurements of the concentration of each element present. Here we can see the experimental setup for measuring the refractive index of an aqueous medium. The refractive index of an aqueous medium can be measured using optical spectroscopy with the help of silver nanoparticles. These nanoparticles act as probes that interact with the medium and produce a surface plasmon resonance signal, which is sensitive to changes in refractive index. By analyzing the spectral properties of the plasmon resonance signal, the refractive index of the medium can be accurately determined.
Thank you for watching. I hope you have learned something new about why optical fiber is used for optical spectroscopy.